Hello, Matt here from chemistrystudent.com. In this video, we're going to look at pH. We're going to talk about what pH is, how to calculate it, and using the pH of a solution to find the concentration of H+ ions present. Before we talk in detail about pH, there are a couple of ideas you need to be comfortable with. According to the Bronsted-Lowry definition, acids are proton donors and bases are proton acceptors. Acids dissociate and split apart into H+ ions and their conjugate base when added to water. Strong acids fully dissociate when added to water. Weak acids partially dissociate when added to water, forming a solution that contains molecules of the acid, H+ ions, and conjugate base ions. Concentration refers to the amount of particles dissolved in a given volume of solution. Usually this is measured in moles per decimeter cubed, as in a concentration of 1 mole per decimeter cubed means in 1 decimeter cubed of solution there would be 1 mole's worth of those particles present. Recap done? Let's go! When an acid dissociates in water and splits apart, the concentration of H+ ions in the water increases. The more acid that dissociates, the higher the concentration of H+ ions in the solution that forms. As a result, the greater the H+ ion concentration in a solution, the more acidic the solution is. This means we can consider the acidity of a solution in terms of the concentration of H+ ions in it. The only problem is that the concentrations of H+ ions in solution can vary enormously, and some acidic solutions have very low concentrations of H+ ions, making referring to the actual concentration of H+ ions rather frustrating and possibly confusing. To make things easier, a scale was developed that is based on the concentration of H+ ions in a solution, and is called the pH scale. As there is such an enormous range of possible H+ ion concentrations in water, the pH scale's job is to take this big range of values and represent them with smaller values that are closer together. This makes the pH scale logarithmic. Now, we don't want to get too mathematical here, and for chemists, we only really need to know how to use a logarithmic scale rather than understand how it works. Still, I think it's really important students have an idea of where these numbers actually come from. The pH scale starts at 0, and a pH of 0 means a solution has a concentration of H+ ions of 1 mole per decimeter cubed. As pH value increases, H+ ion concentration in the solution decreases. A change in concentration by a factor of 10 is represented with a change in pH value of 1. This is referred to as a base 10 log scale, or common logarithm. For example, as a solution with a pH of 0 has a H+ ion concentration of 1 mole per decimeter cubed, this means a solution with a pH of 1 has a H+ ion concentration of 0.1 mole per decimeter cubed. This is because the pH value has increased by 1, meaning a H+ ion concentration decrease of a factor of 10. 1 divided by 10 equals 0.1. The really cool thing about this is if we go up to pH 2, the H+ ion concentration decreases by a factor of 10 again, making the H+ ion concentration in a pH 2 solution 0.01 mole per decimeter cubed. As pH 1 has a concentration of 0.1, divide 0.1 by 10 and you get 0.01. This means an increase in pH of 2, from 0 to 2 here, means a H+ ion concentration has decreased by a factor of 100, so it's got 100 times smaller. Going up to pH 3 would decrease the H+ ion concentration by 10 times again, making a solution with a pH of 3 1,000 times less acidic than for a solution with a pH of 0. If we were to show this on a graph for more pH values, you would get what is called an exponential shape. The pH scale runs from 0 to 14, although solutions can have pH values outside of this range. You can see from the graph that we can cover an enormous range of H+ ion concentrations by using just 15 values, 0 to 14. A solution with a pH 0 has a H+ ion concentration that is 140 trillion times more concentrated than a solution with a pH of 14. Think about that. We have shown a range of H+ ion concentration of 140 trillion times with using a scale that runs from just 0 to 14. This is what makes the scale logarithmic, and although it can seem a bit confusing for students for the first time, it does make dealing with acidity and H+ ion concentration much easier, even if it doesn't feel like it right now. The fact pH is logarithmic does make calculating it a bit tricky, however, especially if you aren't a lover of maths, like me. Without getting too bogged down with advanced maths here, a logarithm is the number of times one number must be multiplied to give another number. For example, we can write 1,000 as 10 to the power 3. For maths students, this is called an exponent. Now, we can see from this that 10 has to be multiplied by itself 3 times to get to 1,000. This can be written in a different way, using what is called a log function. Log 10, 1,000 equals 3. This tells us that to get from 10, the base, to 1,000, 10 has to be multiplied by itself 3 times. The log function can be found on your calculator as, surprise, surprise, log. For example, log to the base 10 100 equals 2, meaning 10 to the power 2 equals 100. Log to the base 10 1,000 equals 3, meaning 10 to the power 3 equals 1,000. Log to the base 10 10,000 equals 4, meaning 10 to the power 4 equals 10,000. If you're still watching at this point, you'll be asking, what does this have to do with pH? Well, we can hopefully see that when the answer of log to the base 10 something increases by 1, this means a 10-fold change to the value of the something in the log expression. Remember, the pH scale is base 10. This means a change in pH of 1 actually refers to a change in H+ ion concentration of 10 times, or 10-fold. If we say the answer to the log function is pH, so pH equals log to the base 10 something, we just said that when the answer to log to the base 10 something increases by 1, that means the something in the expression is getting 10 times bigger. Here, that something is concentration of hydrogen ions, meaning if pH changes by 1, concentration of hydrogen ions increases by a factor of 10. And just to make things a little bit more confusing, the pH scale is negative, meaning the smaller the pH value, the larger the H+ ion concentration value. As a result, a minus is placed in front of the log 10 function, meaning pH equals minus log to the base 10 concentration of H+ ions. Don't forget, however, that this is just one way of writing out this expression. We could also show it as concentration of H+ ions equals 10 to the minus pH. Just like log to the base 10 1,000 equals 3, is the same as 10 to the power 3 equals 1,000. This also describes why a pH of 0 represents a concentration of H+ ions of 1 mole per decimeter cubed. This is because log to the base 10, 1 equals 0. Using these two expressions, we can find the concentration of H+ ions in a solution by using its pH. For example, to find the concentration of H+ ions in a solution with a pH of 6, we just use concentration of H+ ions equals 10 to the power minus pH. The pH value here is 6, meaning concentration of H+ ions equals 1 times 10 to the power minus 6. We can also find pH using concentration of H+ ions. For example, if a solution has a concentration of H+ ions of 0.1 mole per decimeter cubed, we would use the expression pH equals minus log to the base 10 concentration of H+ ions. Concentration of H+ ions is 0.1, meaning pH equals minus log to the base 10, 0.1, given a value of 1. Make sure you get comfortable using both forms of the expression here. Concentration of H+ equals 10 to the power minus pH, and pH equals minus log to the base 10 concentration of H+. So, to summarize, pH is a scale used to represent the concentration of H+ ions in a solution. The greater the value of pH, the smaller the concentration of H+ ions in the solution. The scale is logarithmic to the base 10. This means a change in pH value of 1 represents a change in H+ ion concentration of 10 times. pH can be represented in two ways. pH equals minus log to the base 10 concentration of H+, and concentration of H+ equals 10 to the power minus pH. The scale starts at 0, and this represents a H+ ion concentration of 1 mole per decimeter cubed, as minus log to the base 10, 1 equals 0. If the pH of a solution is known, the expression concentration of H+ ions equals 10 to the power minus pH can be used to find the concentration of H+ ions in the solution. If the H+ ion concentration in the solution is known, the expression pH equals minus log to the base 10 concentration of H+ ions can be used to find the pH of the solution. I hope you found this video useful. Please check out other relevant videos in the links given in the description below, and visit chemistrystudent.com for free notes and revision materials.